Hey guys, what is up? It's your pal Dave back again Sunday live in the lab. And we've got some people in the chat already. We got Ivan and D McGee. Hey guys, how you doing? So here I am back again. I did this Sunday last week, so maybe Sunday's a good day. Not sure, but it's working so far. So a couple of things. First of all, thanks to all the subscribers. Got some new guys. Zorophone, you're back from last time. Welcome back. My YouTube channel hit 10,000 subscribers this week, which for me is totally insane. Like, I didn't expect it to hit 10 subscribers. So 10,000 is really super cool. It's like 5 digits. That's a lot of people. So anyways, that's great, and thanks to all you guys who subscribed. I hope you're enjoying it. Before we go, I'm just going to adjust my camera here. I know that's really not professional, but it needs to be done. Thanks, man. Thanks, Zorophone. Yeah, it's quite crazy. Let me just do something here real quick. Exposure. Technology. There you go. That's a little better. All right, so it doesn't look like I'm underwater in some bunker, even though I am in a bunker. Okay, so what are we doing today? So I've done a lot of videos on MIDI stuff, as you may know, and the one thing I haven't covered is program change messages. And I've been getting a lot of messages from people saying, oh, you know, how do I do program change? I want to make a foot switch to control my whatever, you know, I want to be able to change patches on my synth or whatever. So today we're going to kind of do a quick little thing, and I'm going to show you how to wire up and program a little program change controller. Hey, Alan, you have great works, man. Thanks, Alan. That's really cool of you. Thanks. So what do I got? So I got a Dave Smith Tetra synth that we can experiment on. I've got a little breadboard. I've got an Arduino Uno. I've got a MIDI jack, and I've got a few buttons. All right, and I'm just going to do this off the top of my head, and hopefully it all goes according to plan. So let's start by wiring up our MIDI output jack. And I've done this in a ton of videos. So basically, if I'm looking at the jack from the back like this, there's 5 leads. You have to excuse my drawing skills here. So we've got 5 pins on the back of this jack. Okay? The middle pin is going to go directly to ground. All right? And that's going to tie into the ground pin GND on the Arduino. The outer 2 pins, we're not going to do anything with. They don't connect to anything. This pin here is going to go through a 220 ohm resistor to plus 5 volts. All right, that's 220 ohms, not K ohms, just ohms. And plus 5 volts will be taken from the plus 5 on the Arduino. The other pin on this side is going to go through another 220 ohm resistor and then to the Arduino's TX pin, which stands for transmitter pin. So that's, once again, 220 ohms. Okay, and that's basically our MIDI circuit. So the TX pin on the Arduino, if you don't know, is kind of right at the bottom here. It's actually called digital pin 1, but it has a dual function as a digital, or sorry, a transmitter pin as well when you're doing serial stuff. Okay, and what we're going to do, or what my thought is I'm going to take some of these buttons and we're going to make a little, you push one button, it goes up a patch number, you push the other button, it goes down, right? Real simple stuff. Okay, so let's start. Let's wire up our Arduino MIDI output. Okay, so we'll put this kind of at the edge of the board, give ourselves as much room as possible. All right, there you go. And what did I say? So the middle pin is going to go directly to ground. So what I'll do is I'll jump it, I'll take one of these little jumper wires. Right, and I'm going to bridge the middle of the board and then one more to the blue rail on the board. Okay, so if you're not familiar with how breadboards work, basically these rails on the sides are all connected. So this blue rail, which has a minus side, so that's good to use for ground, is anything I plug in there will be connected to anything else I plug into that. And the red positive rail is also connected all the way across. So I'll use those as power and ground rails. Now these rows here, basically anything in these slots here are connected. Anything in these slots here are connected, and there's a little gap in between. So that's the way if you put an IC chip on there, half the legs will be on this side, half will be on this side, and then you can connect to each leg through the individual rows, right? Did that make sense? I hope so. Okay, so here's a 220 ohm resistor. And you can tell the color code is red, red, brown. Okay, and if you're not sure, use a multimeter to measure your resistance. Okay, so we're going to get one from this pin here, and we're going to jump the middle of the board with it. And the second one, we'll do it on the pin next to it. So remember, these middle pins here, okay? Now, on this side, so what did I say? We're going to go to 5 volts from there. So I'm going to jump from this side of the resistor to the 5 volt rail. And I did the wrong row. All right, there you go. And this side, we said we're going to go to the Arduino's TX pin. Okay? So let's kind of get things a little organized here. And we'll get a longish jumper. So I'm going to put one side on the resistor and the other side on the pin marked TX. All right, and there's our MIDI circuit done. Now, what we'll do is, next we'll do power and ground. And you notice that my Arduino's not plugged in. It's good to kind of connect things a little bit before you power it up. So ground, I'm going to go to the GND pin on the Arduino, and it's going to go to this blue negative marked rail. And this wire, red, so I don't mix them up, will go to plus 5 volts, and we'll go to the plus 5 red rail. And we'll kind of get everything there. That's good. That looks great. Okay, so that's kind of our MIDI. Now we have a basic functioning MIDI out circuit. So what we're going to do next is we're going to add some buttons because I want to be able to select things, right? So here's our button. Maybe we'll add a couple. And if you look at the buttons, they kind of have, you know, a pair of pins on one side, a pair of pins on the other. So these two pairs are connected, and these two pairs are connected. So what you want to do is we're going to put this side to ground, and we're going to put this side to one of the Arduino pins. Okay, so these two sides go to ground. This one will say will go to pin 2 on the Arduino, and this one, let's do pin 3. All right. So let's start around here. And the trickiest part is getting them on the board, but once you do, it's pretty simple from then on. And let's do one next door. Okay, so now we need a couple of jumpers to go to the ground, our blue ground rail. Because remember, everything connected to that rail is going to ground. And we'll do the same for this one. And there you go. Now we'll take a couple of small jumper wires. Let's see what I got here. Yeah, I got a couple of small ones. And this guy is going to go from this leg of the button to pin 2 on the Arduino. And this one will go to pin 3, just like we said. And it's pretty tight. Okay. Pin 3. All right. So now we got our buttons hooked up, we got our MIDI out hooked up. Okay, so now I think we're okay to plug in the Arduino and start programming. And that little sound is the sound of USB victory. Okay, let's change scenes here. All right. So now we've got a fresh, brand new Arduino sketch. It comes set up with the setup and loop functions that are needed with some annoying comments that we'll take out. Okay, so the first thing we have to do is include the MIDI library. And there's a couple of ways to do that. Now, if you go to Sketch, the Sketch menu, you'll see the Include Library. Okay? Now, if you go down this list, you should have MIDI Library. Now, if you don't, and I've done, like in my videos, I've installed it manually, but now the later versions of the Arduino software allow you to do it a little easier. So if you don't have that option, go to Manage Libraries, and you'll get this little pop-up. Okay? Scroll down to M's. I think I've passed it. And get to MIDI, M-I-D-I, MIDI library. And for me, it's saying it's installed, but if you needed to install it, you just select the version. You can go with the latest one and then click the install button. All right, but I've already done it, so I don't need to do it again. Okay, so once you've got it, you've done that, what you need to do is if you're just doing this, restart your IDE, your software, or it won't take, right? You gotta shut it down and restart it. Okay, now we go to include library and MIDI library. And what that does is it types this command for me, which is include midi.h, which basically includes the MIDI library code into my program. Now, to get the MIDI library running is pretty simple, pretty straightforward, but there's a couple of important things you need to do. The first most important thing is we have to type this command, MIDI underscore create underscore default underscore instance with 2 brackets and semicolon. And you notice it turned blue, which means that it was recognized as an actual command, which is great. If it doesn't, there's something going wrong. You might want to check that. Okay, and the next thing we have to do is, well, before we do that, okay, let's, we'll just do the MIDI stuff first. So to start the MIDI, so now we've kind of included an instance of the MIDI library in our program. So, but to actually make it work, we have to start it. So what you can do is type MIDI, all capitals, and spell it right, dot begin, and then in brackets, you can put MIDI underscore channel underscore omni. And that's just, you can actually leave that out, but I tend to put it in, and it's just a simple thing that means it will listen to any MIDI information coming in. Now in our program that's not important because we're not actually bringing MIDI in, we're just sending it out. But if you were, when you start, you can add this command and it will receive every MIDI channel that comes in, which makes it a little easier to troubleshoot, right? Because you may be getting MIDI in and you're wondering why it's not doing anything. It could be because you're sending it on the wrong channel. So MIDI channel omni kind of helps that way. Okay, so that's really it. We now have MIDI active in our program. So Joseph C., how are you doing? Hello, you could search for it and we'll go right in. Cool, okay, so that's, yeah, like there's, they've made it way easier to actually do that. So instead of scrolling, you probably just search, which would make total sense. Thank you, Joseph, for that. Okay, so next thing we have to do, we got 2 buttons. So we have to put the pins in the correct mode for our buttons. So we'll go pin mode, pin number 2, and then comma, input underscore pull up. Okay, so what that does is normally if you install a button to a microcontroller, you need to add a resistor to it. All right, otherwise when you push the button, you're just shorting power to ground and it can damage the microcontroller. But the Arduino, the Atmega chip on these guys have built-in resistors, which is really handy. So if I configure the pin as input pull up, it will enable that resistor and I don't have to add a second one on my board, which is super convenient. And we'll just copy and paste that for pin number 3. Okay, so that's should be all the setup I need to do. Yep. So now we can do our main loop, and this is where we're actually going to do stuff. So first of all, we're going to test if I've pushed a button. Okay? So let's say if, and in brackets we'll do like an if command. If digital read and pin 2, actually we'll start with pin 3 because I just want to try something first. So pin 3 equals low, okay? Now the way we have our buttons hooked up, if we get a low, right, that's a ground signal, that means I've pushed it, okay? We've kind of, because we're using our built-in resistors, it's called active low. So when I push this, the pin goes low, and that means it's pushed. So if digital read 3, and notice the double equal sign, that's something that will trip you up all the time. If I put 1 equal sign, it's saying assign something to a variable. Where if I put 2, I'm saying check if this is equal to this. And if you mix them up, you don't get error messages, which is really messy. So you can type it in, everything looks good, and you're wondering why things don't work. It's a lot of times because of that. All right, and then we'll bracket it and make an if function. So if MIDI 3 equals low, now what we'll also do is we're going to create 2 global variables. And I know globals aren't the best, but they're simple when you're doing a quick little thing like this. So I'm going to write, I'll make a byte. I'll call it patch num equals 0. So I'll just set it to 0 to start with. And a global variable, I'm putting it outside of any functions, means anywhere in my program I can access that, which can be good and it can be bad, but in our case I think it's good. Okay, so we're going to say if this equals low, and I'm not going to do any checking right now, I'm just going to see if this works first of all. Patch num plus, double plus, which means increase patch num by 1. Okay? And what we'll do is we'll send out that patch number as a MIDI command. So to send a program change message, this is how you do it. You type MIDI, that's our MIDI object, and then dot send program change. All right, and it turned orange, so that means it's a recognized command. And for program change messages, they're really simple. All you need is 2 pieces of information. You need the program number you want to go to. So it could be anything. The acceptable numbers are 0 to 127. So let's say it's like 22 is the patch number I want to go to. And then you have to go comma and the MIDI channel you're going to send it on. So we're going to send it on channel 1, but you could change that to any of the 16 channels. Now, that would send a message to my synth saying change to patch number 22, right? And if I know exactly what patch I want to go to, that's a way to do it. But instead, I want to be able to change the patch when I press the button. So instead, we'll go use the variable patch num patch num as my command. Okay, so whatever patch num is, whatever number that is, it's going to send that patch number. And remember, I can increase patch num by pushing the button, hopefully. Now, one more thing we should do is add a little delay, a delay command, and we'll do 200 milliseconds. And the reason we're doing that is when I push this button, it's probably going to read it like a whole bunch of times and send multiple patch increase numbers to this. And that little delay basically makes, slows it down a bit. So, you know, I don't whiz through. It's just going to recognize each press separately. What am I trying to say? My God. So it's basically a debounce routine, but a real cheap and stupid one. So that's good enough for our little demo here, so we'll use that. Okay, let's see everything. So I'll do a quick verify. Oh, before I do that, go to your tools menu. Make sure your Arduino is set to Arduino Genuino Uno and your COM port is correct. And since I plugged it in, it's actually determined my correct COM port, which is great. So let's do a little verify. Cross your fingers. And just give it a sec while you're doing that. I'm just going to head over here for a sec. And we're back. All right. Oh, I didn't save the program yet. So I gotta, yeah, it's telling me to save it. So what am I gonna call this? Program change. Yeah, call it prog change 1. Yeah, okay, there we go. So now we can verify it's compiling the sketch, right? Check for errors. If we see orange writing down here, that's a bad sign, but so far so good. And good, it compiled right away. That's great. It's almost like I know what I'm doing. Almost. Now we can upload. Let's upload. Don't be scared. We'll just upload it. And done uploading. And I could see the little flashies on my thing. I just want to double check. And that's a good way to, you should always kind of, there it goes. I don't know if you can see that, but you can see the TX and RX lights kind of go nuts for a sec. Okay, cool. So, I don't know. Let's try it, see if it works. So, here's my synth. I've got a MIDI cable in MIDI in on my synth, and I'm going to plug it into the MIDI out on my Arduino. And let's go to a better view. And that's a lot of glare going on. Let's see, what can I do? There we go. Hopefully you can see that. Can everybody okay with that? So you can see we're on program 1, bank 1. So if I hit this button, it should go to bank 2. If not, we're in for some troubleshooting. Here we go. Wish me luck. Hey, there you go. Program 2. Push it again. Program 3, 4, 5, 6, 7, 8, 9, 10, 11. Awesome. So that works. That's really great. Okay. What I'm going to do is we're going to do some more work. So I'm going to unplug this just because, it's kind of like I don't like sending random stuff to this through the MIDI cable. So until I'm ready to test it again, we'll unplug it. It probably won't hurt it, but better be safe, right? Okay, so that worked. Now, one thing we should do is set up some boundary checks to make sure I don't exceed the maximum MIDI channel. So I'm going to go if MIDI digital read equals 3 equals low, and patch num is let's see, less than or equal to 1. No, it should be less than only 128. Okay, so let me see. No, 127. Let me just, What's that, Joseph? I think your Twitch box, very creative. Good job. Thank you. Yeah, like this thing here, really useful. I'm really enjoying it. Makes my life way easier. So if it reads, so if patch num goes to 127 and then it comes along, it reads, and I can't go any higher, so yeah, that's good. Okay, so yeah, so we don't want to exceed 127. So as a test, I'm going to initially set patch num to 120, and we'll see if it stops where it's supposed to stop. All right, cool. Plug our MIDI thingy back in. Now, if my thoughts are correct, we should start at, when I push this, it should jump up to 122. Yeah, good. 123, 124, 125, 126, 127. Yeah, so it's actually went to 128 on this because there's no patch 0, right? It's 1 to 128, even though in MIDI terms it's 0 to 127. All right, cool, good, great. Okay, so let's just copy and paste this. Let's go back. Sorry guys, I gotta go back for you. And we'll copy and paste this right underneath. And this is for button 2, which remembers this guy. So button 2 equals low. Now in this case, we don't want to go below 0. So I want to make sure we're greater than 1. Yeah, because would that let me go to 0? Let me think. Logic, thinking. So if I come in, I'm in 1. I want to be able to patch greater than 0. So if I'm coming in at 1, I want to be able to decrease patch. So I'm going to change that plus plus to minus minus. So minus, so I come in, patch is 1, so it's going to let me, that's going to go through. I can go to 0. And the only issue here is we want to go less than or equal to 1 because we're using a byte variable, and what happens when you decrease a byte variable below 0? It doesn't go to minus anything, it goes to 255 because a byte goes from 0 to 255 and it loops around. So if I go, patch 3, 2, 1, 0, and I go one more, it's going to jump to 255, which will be totally out of range. So I want to be able to say less than or equal to 1, so that way is equal to 1, I can go to 0. If it's less than 1, yeah, okay, that makes sense so far. Let's try it. So this should go down. All right. Come on, let's be fearless. Just, what's that, Joseph? It should be 126. Let me see. Maybe I have to go less than or equal to 127. So let's see. 126. If it's less than 126, would that let me? Less than, yeah, because if we're at 127, I want this to fail and not go up anymore. Correct? If it's less than 126, let's see, 126 comes down. It's not less than, it won't let me go to 127. Yeah, I think that's right. I think that's right. These logic things on a Sunday night are difficult sometimes. Okay, well, let's try it and we'll see if things go up in smoke. We'll all have a good laugh. And we're done uploading. Good, great, awesome. So if I push this, yeah, cool. Okay. So this, and sorry guys, I gotta change the thing for you. So this one's going down, this one's going up. When I go to 127, 128, and it stops me, cool. And if I go all the way down, this is gonna take a while. So this R is asking me, so are bytes unsigned by default? Yes, bytes are always unsigned. There's no such thing as a signed byte. There's and DJ, thank you for subscribing, man. Thank you. That's awesome. Welcome aboard. And let's see. Go down 3, 2, 1, 6, 7, 1. And I'm at program 1, and it's not letting me go any further. So I think that works. I think we're good on there. All right. That's great. So now we've got kind of a little remote control. We can switch through all the patches, which is super neat. Now, there's one thing. You notice we also have a bank number. Okay, how do we change that? Now, let me go back in time to when MIDI was first started. Okay, so when MIDI first started, they came up with a bunch of commands and they said, okay, we need note commands, we need controller commands, we need a way to change patches on a synth, and they came up with separate commands for all those things. Now, what they said is, okay, program change, we can have the values 0 to 127. That's all it can fit, but we'll never need more than that. Okay, trust me, guys. There will never be a synth with more than 128 patches. It's just impossible. It would cost too much. It would be insane. Hello, DJ. Hello for Australia. Cool, man. Wow, that's quite a ways. Welcome. Yeah, but that's what they said. And that's one of those old things, you know, when Bill Gates said, oh, no one will need more than 640K of RAM. That's insane. No one will ever need it. Well, you know, you always look stupid when you make proclamations like that. So, of course, they started building synths that could take way more than 127 patches. So they went, oh, okay, what are we going to do? Well, they came up with the bank concept. So you can have banks of 128 patches. So you can have bank 1, 128 patches, bank 2, 128 patches, and so on. So that's how they got around the problem. There's kind of a workaround, but you know, whatever, it works, and it kept MIDI going for quite a while. So let me show you something here. So first of all, I've got to pull up the instructions for the Tetra synth. And that's the first rule in electronics and technology. It's RTFM, which stands for Read the Manual. Okay? So let me get you here. Hacker's Bench Synth subscribed. Wow, that's I think you're going to enjoy this and I'm probably going to check out your channel too. Okay, so here's the Tetra manual, okay? And with all manuals, go right to the back. That's where all the good stuff is. The front is all a bunch of fluff. So we have to find the MIDI chart that tells us how this thing responds to MIDI. I think we're getting there. Where are we? Okay, so receive now. We don't want NRPN. All right, here we go. MIDI messages. So here we have our, where's our program change, okay? So you notice it says program change. The range is 0 to 127, just like we thought. And it's basically saying 4 programs, 1 to 28, which means on your synth, it's going to be viewed as 128, or sorry, 1 to 128, but behind the scenes, it's 0 to 127. Okay, now if we scroll down more, it's receive controller messages. And we should see, oh, there we go. So controller number 32 is bank select. And it's saying, what's that? Hackers, nothing yet here, waiting for parts on my TTSH. Nice. Good to get all the hackers here. So you know it says bank select 0 to 3, because there's 4 banks on this. And selects banks 1 to 4, others ignored, right? So that means if I send bank select 5 or 6 or anything, it's gonna just ignore it and not do anything. Okay, so that's basically how it works. So we need to do a little deal for bank 32. So what we'll do, what are we doing? Tell me what we're doing. We are going to, first of all, add 2 more buttons for bank select buttons. And I'll put these over here. Where am I going? And 1 more for good measure. And these are tight. All right, hopefully that went in. I'm just gonna pull the power on this guy for a sec while I wire these up. And let me just grab some wires. So just as before, I gotta tie one side of these to ground. And always get tons of jumper wires. All right. Okay, one's done. So that's one piece of advice. You can never have enough wires, ever. Ever. And then we'll get 2 little jumper cables, and once again these guys are super handy. Get a ton of them, and we'll put this guy into, where are we at, pin 4. Pin 4, and this guy into pin 5. All right, there we go. And now we got to program some stuff. All right, so let's go back to our sketch. And I'm going to add those, first of all, I got to add 2 more pin mode commands to set those pins. And I do a lot of copying and pasting because I don't like typing too much. But that's fine, there's nothing wrong with that. Okay, so pin mode 3 and 4, input pull up once again. Now we'll copy and paste these guys. And I'll show you what we'll do. Okay, so this is pin 4. and this is pin 5. Now, first of all, we'll set our thing. So remember, now we're dealing with the range of 1 to 4. Okay, and we can't go more than that. So 4 is our top, 0 is our bottom section. Okay, we're going to try that. Now, like I said, bank numbers are not handled by program change messages. They're handled by controller messages, right? Or Midi CC messages that I've covered in a couple of videos. So Midi CC controller number 32. So we have to change our program change to a control change. So all we have to do is change program to control. And we're going to make a new byte, and I'm going to set this back to 0. And I'm going to make a new global variable byte bank number num. Sure, why not? That makes total sense. Okay, so that's going to store our bank number. So we also have to change that to bank num, and this will go bank num as well. Good, excellent. Now, oh, here's another thing. So program change numbers only have 2 variables, right? The number of the patch you want to go to and the channel number. Midi CC or control change commands have 3 variables. The first one is the controller number. So what was it again? 32, right? So we got to go 32, comma, patch num is the value I'm going to send to that controller number, and channel is 1 once again. So here we go, 32, comma, patch num, yeah, is that, and oops, it's bank num. What are you doing, man? Bank num. So you gotta be thinking all the time, and this has got to be bank num as well. And this this has to be bank. All right, disaster averted. All right, that looks good for me. Let me just do a quick verify. And everything looks good. Excellent. So I think we're good to go. Let's plug this in and we'll upload it. And you notice I forgot to pull out my MIDI cable, but nothing went up in smoke. So that's great. I'm just going to reset this to make sure everything is good. Okay, now if everything works and everything is good in the world, this is going to change my bank numbers. This is going to change my patch numbers. Here we go. Did it? Yes, it did. Did I do it backwards? Yeah, I did it backwards. Hang on a sec. I want to. I want it to be the same as the other 2 pins, so I'll do 5 here and 4 here. Yeah. Yep. That's right. Kind of had them in the reverse order. Duncan, hi from Australia. Do you have a link to the MIDI library you're using? I'll show you how to put that in 1 sec. Once I've done this, I'll show you how to install it. All right, here we go. Now let's go back. All right, wish me luck. Bank 2, bank 3, bank 4, and we can't go farther. Bank 3, bank 2, bank 1, and we can't go farther. There you go. So now we got bank up and down, and we've got patch up and down. So if I didn't know better, I would think that's kind of like a little MIDI controller that's controlling patch numbers and bank numbers. You know, what do you think? That's cool, right? Okay, just for Duncan, we're just gonna, I'll show you again how to do the MIDI library. So if you go back, watch the VOD of this, and it will show how I created the program. But really quickly, if you go to Sketch and include library, it should be here. And if it's not, you can add it easily. If you go to Manage Libraries, and who was it? Joseph gave me the cool little option. Maybe I'll do a search. So if you type in MIDI, and there you go. So we don't want USB. There you go. So you want to scroll down until you get to MIDI library, right? You see for me it's installed, so I can't do it again. But if you go to more info, you can select the version, just use the latest version, and then click install. And it will install it into your Arduino IDE. Make sure you once you've done that, make sure you shut the Arduino IDE right down and then restart it for it to show up. And then you can go to Sketch, include library, and just click on MIDI library, and that will type this command in for you and basically add it to your sketch. Joseph, awesome, great, good job. Thank you, Joseph, for the vote of confidence. That's great. So guys, I think that's successful. Let's see, Duncan, I noticed there's a few libs on the web. Make sure it's the right one. So there's a few libraries. The best one is by a guy named 47 Effects, and that's the one that Arduino has included in its IDE, so it's probably the best one. Does the standard library handle NRPN? That's something I gotta check on because I haven't tried that myself, and I think it might, or you might be able to hack away around it, but I'd have to verify that for you. Let's see, Lego Steve B, how you doing? Maybe for the bank small number you can use only one button and use a modulo command to wrap around. Very good point. You know, that would totally work too and save you one button. So he's saying just have one and it would just increase bank 1, 2, 3, 4 and then back to 1. And the modulo command basically wraps it around. Duncan, awesome video by the way. Thanks. Awesome. Thank you, Duncan. So guys, I think this is a successful little adventure we had. And thank you all for hanging out. That was really cool. So, you know, I used to do this on Twitch, but I'm kind of digging YouTube because, I don't know, it's kind of working better, and I've got a lot of subs on YouTube, so it kind of works a little better for me. Let's see, Lego Steve, great job. You actually inspired me to get into making some MIDI controllers. That's what I want to do. I want to inspire people to hurt themselves with electronics. That's my goal. So thanks to all you guys, and I will see you next time. So as always, you know, follow me on YouTube, Twitter, Facebook. The Facebook community is really great. Yeah, thanks again. So I'll see you guys next time. Take care.